Right, what we're going to look at now is called coefficient of friction. Now, it's not a difficult concept, but it's one we don't really teach in NCEA. What I'll do to start with is just draw a ramp, and we'll use that to try and discuss the ideas. So if we had a box on a ramp, obviously what's going to be holding it up there is friction. Now we can draw in the weight force. Fw, as usual, is the weight force. Now it's going to have two components. A component that goes parallel with the ramp and a component which goes perpendicular to the ramp. The angle of the ramp, theta, is the same as this angle here, theta. So these two angles, this one and this one, are the same. I won't prove it. The force parallel with the ramp can then be characterized as mg sine theta. That's the accelerating force on that box. The force perpendicular to the ramp, mg cos theta. You've all done that before. Those two vectors, net result is the weight force. The only one that's going to have a reaction force is mg cos theta. So there'll be a force up from the box, support force if you like, mg cos theta. So what we have, or the relationship between that and the coefficient of friction, is that the biggest the frictional force can be, or the coefficient of friction, is equal to that mg cos theta. So when it's equal to it, u equals 1. So mu is the coefficient of friction. So if it is multiplied by the support force. So if mu equals 0.4, then the friction, Ff, will equal 0.4 times mg times the cos of theta. So the coefficient of friction, this one here, just multiplies the reaction force by what you've experimentally determined the coefficient is. So we know the most we could have is mg cos theta as our reaction force. That's what limits things like stopping on roads, is that you can't have a force greater than your reaction force to your weight force. That would be the best friction you could possibly get, and therefore there is a limit to how much you can decelerate. So let's find a formula for acceleration. So we've got two forces operating. We've got this downwards force, mg sine theta, and we've now got a backwards force, friction. So the net force is going to be equal to mg sine theta, we'll just call it F net, mg sine theta minus mu mg cos theta. Alright, so if we want to know the acceleration, we just divide both sides by the mass, and we'll find out that our acceleration is going to be equal to g sine theta minus mu g cos theta. We could take the g out, and we've got sine theta minus mu cos theta, and that's what the acceleration is equal to. So this was just a brief little looking at the coefficient of friction and how we use it. It does come up sometimes in scholarship.